So here is a problem. It's no trick. It's really as straightforward as it looks. It asks you to calculate or write down the expression for the equilibrium constant. So again, it's going to be K is equal to products over reactants, but we're going to pay attention and see that the reactant is a solid, one of the products is a solid. We don't include solids, we don't include pure liquids. So in this case, the only thing that will contribute to the equilibrium constant is going to be that concentration of O2, and we have to raise it to the coefficient, which in this case is the fifth power. So our answer is going to be that one. This problem 5 is no different. It's the same idea that we just have to pay attention to what are the states or the phases of the reactants and the products, and we're expressing the equilibrium constant for this reaction. We have products of it's KOH, and it is raised to the second power because of the coefficient, and then it is the concentration of H2, raised to the first power in this case, all over, well, one's a solid and one's a liquid, so that in itself is going to be our expression. The KOH is squared, and the hydrogen is not, so that looks like it is going to be our answer right here, because it's hard to see, but that's a -2 in that one, so that's our right answer for number 5. Moving on to number 6. Now, it's going to be tempting when you see these problems. You're going to think, oh, everything is an equilibrium calculation, and we have to do our ICE table. But not always. I am going to ask you some very straight chords like this one. So I've asked you now several questions where you had to actually write down what the expression for the equilibrium constant is. Now we put the numbers in. We're told at equilibrium we have a pressure of CO2 that's equal to 0.41. I'm sorry, it's 0.41 atmospheres, and that has to be squared over the pressure of the CO squared. So in this case, that is 6.8 times 10 to the minus 11, and that quantity for CO is squared times the pressure of the O2, which in this case it's given as 1.3 times 10 to the minus third. So 1.33 times 10 to the minus third, and that's raised to just the first power. So you do that multiplication, and you'll find out that that answer is going to be, for this problem, is this one, 10 to the 20th.